Let's build the cozy cottage. So we know right now we're looking at a section view, so pretty much a cut right down through the middle of the house, and we can recognize some things. We can recognize the basement, the first floor, our second floor, and of course the roof. Now what we need to do is we need to start all the way on the very bottom and build our way up. So we're looking at this right here, that, and that. What is the name of those things? You're right. Footing is correct. So we have a footing, a footing, a footing. On top of the footing is the foundation wall. That foundation wall, it doesn't say it, but it's centered on the footing. And again, this is called the T foundation. You can see the footing here is 1 foot 4 inches wide and it's 8 inches thick. And the foundation wall is an 8 by 16 inch CMU. So I know that concrete masonry unit, so I know that this is 8 inches. Again, these things are never seen, right? You never see footings. They're either buried under dirt, under a foundation wall, or under a concrete floor. So when we go to look at our foundation plan, we're showing the footing with a dashed line. We call that a hidden line. So from this drawing, the carpenter would make the forms so that the mason could come and pour the continuous concrete footing. Let's look at some pictures of the footings. So what we have here, this is the finished footing. Okay, so this is after the footing's all done. So you can see they dug a hole, and now you can see these ribbons of concrete all around. And notice they are continuous footings. So this one flows into this one, it flows into that one, it flows into here. So that's important to know about footings, that they have to be one whole entire big huge chunk. All right. Let's go ahead and look at some more. So here you can actually see the mason. So this is a mason, and they are placing the concrete in these forms. He's smoothing it out. And I'll go back to here. This is the rebar, reinforcing bar. So keep in mind what's going to happen on top of this footing would sit the foundation wall. We have to anchor the foundation wall into the footing. So what we do is we put these steel bars up. There's our mason placing the concrete and finishing the concrete. This is a home renovation, and I want to point this out because we have these in our cozy cottage. This steel column right here and a steel column right here, those are called lolly columns, and they're going to be holding up a girder that holds up the first floor. And what happens, right here is the old lolly column, and right here is the old lolly column. What happens is a lot of times they're made out of metal. And if you've ever had any experience with basements sometimes have moisture, sometimes they get water in there, and after years and years and years, what happens is the metal columns rust out. So I know what they're doing here is they have to replace these columns, and they've actually jackhammered out the whole concrete floor. But I just want to point this out, right? That column, they put a new column in here. That column, you just can't set it on the ground because there's a lot of weight pushing on here. It'll just sink down into the ground. And you just can't set it on the concrete floor either. We need something thicker. So here what they're doing is they're pouring footings or making the forms to get ready to pour the footings for those columns. So here's a better picture of it. So there is your steel lolly column. This is our built-up girder. You can see it's made out of 3 pieces of lumber. This here, right around here, that's the concrete floor. And this is the footing, this big, huge, massive chunk of concrete, right? It's going to spread the weight out of whatever weight is on this pole so that this huge chunk won't sink into the ground. And therefore, if it doesn't sink into the ground, this won't sag. All right, and one more picture Another picture of the forms that are needed for the footings. And so again, we're going back to, maybe what happens is the carpenter is making the forms and the mason's going to come and place the concrete. And so what happens, as you can see from this picture, once the concrete is cured, we strip the forms off and then you reuse that wood for a different structure. Just want to point another thing out. These pictures of a building that's much more complex than ours, right? You can tell they have lots of, the shape of the walls is lots of ins and outs and different different nooks and things like that. So we have a much simpler example. All right, so we're ready to build. Problem though, what we've got is we've got a lot of measurements in feet and inches. Everything's in feet and inches. And working with feet and inches is kind of difficult. What we need to do is we need to be able to work with just feet or just inches. And I got to tell you, it's a lot easier just to work with inches. So we need to do some carpenter math. So let's do this. I think you all know that 12 inches equals 1 foot, right? 12 inches equals a foot. There are 12 inches in a foot. Another thing we need to know, that if we have a number and we multiply that number times 1, the value of the original number doesn't change. 300 times 1 is 300. Let's do that again. Let's say 4. What if I multiply 4 times 1? 4 times 1 is still 4. Okay, so that is a rule, a law that's going to help us out. If you multiply any number by 1, its value doesn't change. All right, so let's go back over to here and let's figure this out. Let's say that what's the value of 1 over 1? 1 divided by 1 equals 1. I don't know, 2 divided by 2. 2 divided by 2 equals 1. What if I did this? What if I did 12 inches divided by 1 foot? Right? That really equals 1. Unitless, but it equals 1. And then also 1 foot divided by 12 inches, right? It has an equivalency of 1. It has no units anymore, but it's 1. The reason why we want to know this is because we need to convert some things to inches. We have this 31 feet 4 inches. I want to know how many inches that is. So let's do this. If I have 31 feet, and I'm hoping this is a review from science class, we need to get 31 feet into inches. How do we do that? Well, we multiply it by 1, right? We're going to multiply this by 1 so that the value doesn't change, just the units do, all right? And so what 1 are we going to multiply it by? So this is what I call the chosen one. So that right there is a 1, and that right there is a 1. I'm just going to, we'll say this is the A and this is the B, all right? So I want to multiply 31 times this one or this one so that my answer is in inches. So what we want to do is if we have, and let's do this, let's say that this is a fraction. This is 31 feet over 1, right? By the way, that right there, right? That's the foot symbol. That's the inches symbol. 31 feet over 1. I can multiply this by 1 and not change its value. What I want to do is I want to change the units. So I'm going to choose, in this case, I'm going to choose A, because here I got feet in the numerator, and over here I have feet in the denominator, so the feet are going to cancel out. So let's do this. Let's do 12 inches, and this is 1 foot. Okay, I'm going to do a math equation here. Before I do any math, I'm going to do this. I got foot on top, I got foot on the bottom, so I cross out that units. Those units cancel each other out. And there's no units here. So what's going to happen is my answer is going to be in inches. So I'm going to just go ahead and I'm going to put my symbol right here. I'm going to put my inches down. So now really what I just have a simple math equation. I got 31 times 12. 31 times 12 is 372. And then I divide it, and 1 times 1 is 1. And so 372, I better long form this here, right? 31 times 12 is 372 inches. And then I got 1 times 1 is 1. So really, 372 divided by 1 is still 372 inches. So going back here, 31 feet equals 372 inches. But now I've got the extra 4 inches. So I'm going to do this. I'm going to do plus 4 inches. All right, so if I add that together, I'm going to get 376 inches. So let's do this to my drawing. 376 inches. We're going to have to do this a lot. All right, so you're going to use your calculator. You're going to tell me what is 27 feet 4 inches in inches. So you're going to convert 27 feet 4 to just inches. You're going to convert 15 feet 8 inches to just inches. Right here, we've got 2 feet, 2 feet, 2 feet, 2 feet. That's typical. Convert 2 feet to inches. Here the footing is 8 inches thick. It's already in inches. This, we said, was already inches. So now what we need to do is we need to convert 1 foot 4 inches to inches. So the answer is 16 inches. So the whole thing here is 16 inches. The wall is 8 inches. The wall is centered on the footing. So 8 inches taken away from 16 inches is 8. And I said it's centered. So right here, what we've got in that spot right there is we've got 4 inches right there and 4 inches right there. So let's go ahead and see how that translates to this picture up here. I'm going to go right here and I'm going to say, right, the width of the footing is 16 inches. The width of the wall, those are the two continuous lines, the width of the wall is 8 inches. And I just said that from the edge of the footing to the wall on the outside is 4 inches. And the edge of the inside wall to the inside footing is 4 inches. So this is all like math that a carpenter would actually have to do out in the field. They've given you all the information. It's just you have to do some addition, subtraction, multiplication to come up with your answers. All right, so the 15 foot 8, that turns out that was 188 inches. The 27 feet 4 inches was 328 inches. So don't forget what we're doing is we want to make the footing right now. So this 328, that's really dimensioning to the concrete foundation wall. I need to know this, or you need to know this. We want to go from the outside of the footing to the outside of the footing. So we can see it's a little bit bigger than 328. 328. We know we have 4 inches up here, and we know we have an extra 4 inches down here. So it's 4 plus 328 plus 4. So that, I believe, is 336 inches. Well, same thing up top. We need to know the outside of the footing to the outside of the footing. So this little distance right here, this little space is 4, this little space is 4. So we have 4 plus 376 plus 4. That's going to be 384 inches. So we can deal with that. So now I know the outside of our footing. Okay, now we need to find these. Okay, we need to actually make those footings at the same time. So we've got a note down here. It says 15 feet 8. From the center of the girder, which is going to be the center of that lolly column, it's 15 feet 8. But don't forget, this foundation wall doesn't exist yet. We're laying out the footings. So it's going to get a little crowded in here, but I'm going to do this. Right? So we're going from the center, still measuring from the same spot here, but here I extended it out 4 inches. So I'm looking at 188 plus 4, that's 192 inches. All right, now they're getting even trickier on us. Who's there?
What's up?
Not much. I gotta figure out how to pause my video.
Oh, I'm sorry.
That's all right. All right, so here they're making life a little more difficult for us. Look, it says 4-inch diameter steel columns, 3 places, evenly spaced. So what we need to do is we need to figure out what this space is, what that space is, what that space is, and what that space is. So again, an example of some real-world math that a carpenter might have to do. So let's go ahead and look at this. What we want to do is we want to know really from the edge of the foundation wall to the center of here, to the center of here, to the center of here, to the edge of the foundation wall. We need to know those 4 sizes. So the first thing we need to do is we need to figure out how far it is from the inside of the foundation wall to the inside of the other foundation wall. So from inside to inside. Whoops, a little too far. All right, well, what do we got? We've got 376 inches. This is 8, and this is 8. So 376 minus 8 over here and minus 8 over here. If we do the math, that is 360. So now we're saying we need these distances. We need this, 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 and this all to be the same. So 1, 2, 3, 4 spaces. 4 goes into 360. How many times? 90. All right, I think we have enough information now to go ahead and start building our footings.